Hi dear parents, welcome back to another math hour. Today I'm going to teach you how to deal with direct variation problems. This is a new topic we're learning in class. And first things first, I got to give you a definition of direct variation. Direct variation basically means you have a coordinate graph, okay, that looks like this of course, and the line in that coordinate graph has to go through an origin, okay? Basically, the line or the linear equation graph has to go through the origin. In other words, 0, comma 0. That's what direct variation basically means. As you can see over here in these examples, you can see that the line, the linear equation line, cuts right through the 0, 0 point, the origin. And that's why this is a direct variation. Same thing over here. You see that it cuts through 0, 0. That's why it's a direct variation. This also, even though it's going the other way around, it still cuts through the origin, there, direct variation. This also cuts through the origin, 0, 0, direct variation. That's what a direct variation graph is basically. The line cuts through the origin, 0, comma 0. Let me show you some problems with this thing. Here's a typical kind of question you could get with direct variation. For example, find the equation of a graph that goes through point 0, 0 and minus 7, 4, and write your equation in y equals kx format. So first things first, there is a specific type of equation that the direct variation is based on. And that equation is this: y equals k multiplied by x. Okay? The y and the x values come from the coordinates, and this k over here is known as a coefficient. Okay? Coefficient. I think that's how you spell it. And basically, coefficient is a number that stays the same, whereas x and y can change. I'm going to show you how this works in this particular problem over here. 0, 0, minus 7, 4. So I need to somehow find the equation of a graph that goes through the origin 0, 0 and also goes through point minus 7, 4. And here's my formula, the direct variation formula, y equals k times x. Now, 0, 0 doesn't help me out. I'm just going to ignore it. It doesn't help me in any way because it's just going to make my equation 0. So I'm going to take minus 7 and 4. And I know that minus 7 is on the x-axis and 4 is my y value right here. So why not substitute? Let's substitute them in this formula. So y is 4, k is k, I don't know what that value is yet, and x is, in parentheses, minus 7. Okay? I just substituted it. And I'm going to clean up a little bit because right now it doesn't look too good. So if I multiply this out, I'm going to get minus 7k. Remember, number always comes in front of the variable, equals 4. Okay? So all I did was multiply k times minus 7, and I just flipped it around, just to make it look good. Okay? I gotta solve for k. So minus 7 is in here. Let me get rid of that. Just divide it by minus 7, and divide this by minus 7. You see? Cancels out, k is free, and the coefficient is basically minus 4 over 7. Okay, now we're not done yet. We've just solved for k. I still need to write my equation in y equals kx form. So all I'm going to do is take this k value and substitute it right over here. So my final answer will be y is equal to minus 4 over 7x. And this will be my final answer. And this equation represents the line that cuts through the origin 0, 0 and minus 7, 4. Okay? That's how you do it. Let me show you another example. Take a look at this question. Find the direct variation equation with x is equal to minus 5 and y is equal to 12. Well, although they wrote it like this is just a coordinate point. In other words, it is minus 5, comma 12. And I need to find my direct variation equation, so I'm going to use y equals kx again. And well, since they gave me the coordinate points, let's go ahead and plug it in. This is my x value, this is my y value. Let's plug it in. This will be 12 is equal to k multiplied by minus 5. So let's multiply this together and let's flip it around. I'm going to get minus 5k is equal to 12. I want k to be independent on its own, so I'm going to divide this by minus 5, and I'm going to divide this side also by minus 5. Minus 5 cancels. K is equal to minus 12 over 5. You see? And now what do I do with this? I'm just going to plug it back in to this equation. So my final answer will be y is equal to minus 12 over 5k. Oh, sorry, minus 12 over 5x. And that is my direct variation equation. You see, like kids? That's how you do it, okay? Let's try another example. This time, let's you go to a word problem right over here. Check this out. Now, believe it or not, we could use direct variation knowledge to help us with word problems where proportion is important. Okay, direct variation and proportion are exactly the same things. So let me show you how this works over here. Trailblazers Incorporated is known for making high-quality suits. If they take 9 days to stitch 90 suits, how long will it take them to complete an order of 180 suits? Now, although this is a word problem, this is exactly the same thing as we did over here in this equation and exactly as we did over here. We need coordinate points. And in this case, they gave us two numbers which we can turn into a coordinate point. 9 days, 90 suits. So I'm going to just turn this into a coordinate. 9, comma, 90. You see that? And I am going to use my direct variation equation, y equals kx, and I'm going to plug in my values, x and y. So it's going to be 90 is equal to k multiplied by x, which is 9. When you multiply this out, I'm going to get 9k is equal to 90. I just flipped it around. And then if I want k to be independent, I'm just going to divide this side by 9 and this side by 9, cross it out, and I found out that k is equal to 10, because 90 divided by 9 is 10. Alright, now let's plug it back into the equation, and I get y is equal to 10x. Okay? Now what I've got over here is my direct variation equation, which can help me solve this problem. How long will it take them to complete an order of 180 suits? Now if you go back to this, when we did the coordinate points, the x represents days, right? And the y represents suits. So if they're asking me for 180 suits, suits is in the y value, so I'm going to take this number and plug it in right over here where the y letter is, the variable. So I'm going to get 180 is equal to 10 times x. And I'm going to now solve for x. How do I do that? You divide both sides by 10, by 10. 10 goes, cross it out, and 18 divided by 1. Final answer, x is equal to 18. So the answer is, how long will it take them? The answer is 18 days. You see that? We use the direct variation equation to help us solve a word problem.